Section 6.4 says ideas of risk and life expectancy. And so in this section, we're going to be dealing with more relative probabilities, relative frequency probabilities of situations where we measure how many occurrences happen out of a certain number of people in the population. So for instance, travel risk is often expressed in terms of the accident rate or the death rate. For example, suppose an annual accident rate is 750 accidents per 100,000 people. This means that within a group of 100,000 people, on average, 750 will have an accident over the period of a year. The statement is, in essence, an expected value, which means it also represents a probability. It tells us that the probability of a person being involved in an accident in 1 year is 750 out of 100,000, or 0.0075. In this example here, the figure shows that the number of automobile fatalities and the total number of vehicle miles driven among all Americans for each year over a period of more than 4 decades. In terms of death rate per vehicle mile driven, how has the risk of driving changed? So if we look at the graph here, this line represents the number of miles driven, so we can see how the number of miles driven is going up. The bars represent the number of automobile accident deaths. And so we can see how the number of deaths has varied, but it looks like overall it's been trending downwards as it goes along here from past into later years. So here's how we're going to calculate the fatality rate, starting from 1970. The way we do this is we take the number of deaths, which there's 52,000, divided by the number of miles driven, and there were 1 trillion miles driven. So when I divide 52,000 by this 1 trillion, it comes out to be this really, really small 0.000000052 deaths per mile. Now this is kind of a hard number to read, so what I'm going to do is multiply it by 100 million. And when I multiply that really small decimal by 100 million, it changes it into 5.2. In essence, what we've done here is move the decimal point back all the way to here and put it with the 5 in front of it, behind the 5 at 5.2. So that would mean 5.2 deaths per 100 million miles driven. Let's compare this to the 2015 numbers. In 2015, there were 34,000 deaths, so already less than 1970, for over 3 trillion miles driven. So that comes out to be this decimal number for the deaths per mile. And I'm going to multiply that by 100 million again to get 1.1 deaths per 100 million miles. And so we can see how the comparison now, the death rate is much lower in 2015 than it was in 1970. In contrast, for an 11-year period from 2002 to 2012, the total number of deaths in commercial airplane accidents in the United States was 158 for an average mean of about 11 deaths per year. By the end of this period, the total number of miles flown by commercial aircraft was about 8 billion per year. Use the numbers to calculate the death rate per mile of air traffic. Compare the risk of flying to the risk of driving. So I'm going to do the same type of calculation to find the death rate for aircraft. It had 11 deaths and 8 billion miles. So we take 11 divided by 8 billion. It comes out again to be a really small decimal number with lots of zeros. So to show how I'm doing this calculation here, I'm going to use a calculator to do the 11 divided by 8 billion. Just to show what would happen if you do this in the calculator and you get a really small number like this one, it might could tell you something like this. Make this a little bit easier number to read. Again, I'm going to actually multiply this by 1 billion. When I do that, I get a much easier number to read. Here it's 1.375, but we're going to go ahead and round that up to 1.4 to make it a little bit easier again to read. But anyway, that's what happens in the calculator when you get these really small numbers. But a lot of times we're going to multiply that then by another number to bring it into something a little bit more reasonable. So here's again what I did in the calculator. We multiplied by this really small number by the 1 billion and then rounded to 1.4. And what that means is 1.4 deaths per 1 billion miles. So whatever number I'm multiplying by here, in this case a billion, that's going to tell me what the death rate is per that 1 billion miles. So let's switch the conversation over into birth rates. And we can consider much of the same process for these as well. It says compare the birth rate per 1,000 for the United States to the birth rate per 1,000 for California. So for the U.S. birth rate, what I do is I take the 3,952,937 births divided by the total population of the United States, and that comes out with 0.0125, and that's going to refer to the number of births per person. But let's write this as the births per 1,000 people. So if I multiply this by 1,000, it's going to change it to 12.5, and that's going to now be 12.5 births per 1,000 people. So that's that 1,000 referring to per 1,000 people, but that's a lot easier number to read than that decimal we have up above. Similarly for California, we'll take the number of births, which is here over 500,000, divided by the total population of California, and that gives us a birth rate of 0.0131 births per person. To compare this up with the same number for the United States, I'm going to multiply that by 1,000, and that'll change it to be 13.1 births per 1,000 people. So another comparison here, we can see how the birth rate is a little higher in California than the United States as a whole.